Question number 3.298. A wire is shaped as a semicircle of radius A, rotate about an axis O and O dash with angular velocity omega. Right? And the rotation axis is perpendicular to the field direction of the magnetic field. Okay, this axis is perpendicular to the direction of magnetic field definitely, and this magnetic field is given as. Right. So, neglecting the magnetic field of induced current, find the mean amount of thermal power being generated in the loop during this rotation period. Okay, so here we need to ignore the induced current by the magnetic field. Now see, when this loop is rotating in the magnetic field, then there will be flux change, and that flux change would lead to the induction of EMF. Okay, so basically the flux crossing through this loop is equals to V dot S, where S is surface area. So if at any instant this surface area makes an angle theta with this magnetic field B, then theta would be equals to omega into T, because it is rotating with angular speed omega. So we can write phi equals to B into S, right, into cos omega T. So B into area of this semicircular ring, that is pi A square by 2 into cos omega T. Okay, so now the induced EMF due to rotation of this coil is equals to minus d phi over dt as per Faraday's law of induction. So this is d over minus d over dt b pi a square over 2 into cos omega t. So from here we'll get the EMF induced is equals to b pi a square into omega by 2 into sine omega t. Okay, so this is EMF induced. So this much potential difference will be developed across this resistance, right? So current passing through this resistance is EMF induced divided by resistance. So we'll get pi a square omega over 2r into sine omega t. Right. Now the question is asking for the average heat dissipated due to rotation. Basically, resistive power loss. Okay. So power is equals to E into I. So from here we'll get that this power is 1 over R into b pi a square omega over 2 whole square into sine square omega t. Right. So we need to calculate average power. Average power is simple area of the graph divided by the time period. It means we need to integrate this power equation over 0 to 2 pi and divide that by time duration of 2 pi. Right. So this is 1 over r, the constant term we are taking out, b pi a square omega by 2 whole square integration 0 to t sine square omega t, or 0 to pi we can take 0 to 2 pi, and divided by integration 0 to 2 pi d omega t. Right. So now we can change this sine square term like sine square theta is equals to 1 by 2 1 minus cos 2 theta. Right. And if we integrate throughout the period, then the integration of this term is 1 by 2, and whenever we'll get a symmetric trigonometric function, then the integration of symmetric trigonometric function over a complete time period is equals to 0. Okay, here you can see that. If we have a cosine curve, then area above the axis is equals to area below the axis. So we can directly substitute this total integration as 1 by 2. So from here we'll get average value is equals to b square pi square a to power 4 omega square over 8r. So this is final heat generated due to rotation of the square.